So as Natalie indicated at the outset, there's a growing perception that there may be a compelling imperative for large-scale deployment of carbon dioxide removal technologies if we're going to meet climactic goals, whether it's 1.5 degrees Celsius, 2 degrees, or perhaps even beyond that. At the same time, there's also a growing perception that there's a need for international governance of those approaches, whether it be because we want to optimize the deployment of these technologies, whether it's because we want to ensure that we coordinate the deployment of these technologies in conjunction with other ways of responding to climate change, including adaptation and reducing emissions, and because we also know from some of the discussion already, and I'll talk about it more, there are some potentially very serious risks from a standpoint of the environment as well as socioeconomic justice in terms of deployment of some of these technologies at scales that may be unsustainable. Okay? And so what I want to briefly talk about is what international institutions may be brought to bear to govern carbon dioxide removal research and or potential deployment. And I want to look at both some of the institutions that have already started looking at carbon dioxide removal approaches, as well as the institutions that I think may make sense in the future and the more general rules of international law that may ultimately apply. Okay? So first of all, in terms of the current institutions, about a decade ago, a number of different entities began to conduct field research on one kind of carbon dioxide removal approach that we haven't talked about yet today, which is called ocean iron fertilization. Okay? The idea behind ocean iron fertilization is that we fertilize some of the world's oceans that have a shortage of a critical micronutrient for phytoplankton production, which is iron. And by seeding those areas with iron, we increase phytoplankton production. They take up more CO2. Some of that ultimately gets stored when the phytoplankton die. Okay? Well, when we began to engage in that, two international entities freaked out. Okay? One was a convention we call the London Dumping Convention. The other one was the Convention on Biological Diversity. And both of them were concerned about the potential environmental impacts of seeding the world's oceans with large amounts of iron. Okay? So first of all, let's look at the London Dumping Convention and the approach that it took. Okay? So in 2008, the London Dumping Convention passed a resolution on ocean fertilization, right? And it agreed to several things here, right? First of all, it indicated that you could engage in what it called quote-unquote legitimate scientific research in this context. And that's an important thing to remember, because some NGOs claim that this resolution imposed a moratorium on an ocean iron fertilization and any kind of ocean-based carbon dioxide removal approaches, but it didn't, right? It acknowledged that there was a role for legitimate scientific research. On the other hand, it wanted to ensure that it was strictly circumscribed. Okay? So the second thing that it called for was to adopt an assessment framework, okay? To require risk assessment anytime an entity wished to engage in an experiment for ocean iron fertilization. Okay? And then the last thing it said to ensure even more circumscribing is that it said that the only kind of ocean iron fertilization activities that could occur would be scientific research. And so you couldn't commercially deploy these technologies, seek to sell these credits, for example, under the Kyoto Protocol or on voluntary carbon markets or anything of that sort. In 2010, they established the risk assessment framework, right? And you can see here, standard sort of environmental assessment. One of the things that needs to be highlighted here, of course, is that this is a bit blithe, okay? When it comes to most carbon dioxide removal approaches, including ocean iron fertilization, one of the major questions that still exists is, first of all, do we know what all of the risks are that we should be assessing, right? Risk characterization. And that's largely a black box when it comes to a lot of these approaches to date. The second question was, are we able to adequately assess the magnitude of risk that may occur if we were to deploy these technologies at large scale? right? And that remained speculative. But nonetheless, they put this in place. Okay, now this approach and these resolutions that were passed are not legally binding. Okay, when this regime passes a resolution at one of its meetings, it doesn't legally compel its parties to do it. It's merely a recommendation. Okay, so that was one major limitation of this approach taken by the London Convention. But move forward, and in 2013, the parties proposed an amendment to what was called the London Protocol. And the London Protocol is contemplated to be the successor to the London Convention, right? It only has about half as many parties right now, but eventually the idea is that everybody's a part of the convention will join the protocol, and the protocol is a more sophisticated way to regulate the dumping of materials into the world's oceans. And one of the things that they recently proposed in 2013 was an amendment that would regulate what they call ocean geoengineering. Okay? Now, we haven't said the G word yet today, right? But it's there, okay? Carbon dioxide removal is classified by many people as one of the two subgenres of geoengineering, large-scale technical interventions to address climate change, as it's defined by the NAS. The other large category is called solar radiation management, which are efforts to reduce the amount of sunlight that reaches the world's Earth. Okay, so these guys classify ocean iron fertilization, one of the carbon dioxide removal approaches, as geoengineering. And they sought to pass a binding legal amendment to their protocol. Okay, and this is what it would require. First of all, it would expand the potential purview of what the London Convention would regulate to all, quote-unquote, marine geoengineering activities, okay? So this would include other kinds of carbon dioxide removal approaches that might occur in the world's oceans. For example, there's been proposals to add limestone, okay, to the world's oceans to increase its alkalinity and to enhance the uptake of carbon dioxide, okay? That would be another one of these approaches. There's been efforts on the solar radiation management side, for example, to create huge amounts of microbubbles on the world's ocean surfaces to reflect more incoming solar radiation back to space to reduce radiative forcing. Okay, so this convention this amendment could potentially regulate not only ocean iron fertilization, but could regulate some of those other activities if we decide to do them in the future, either in terms of research or in terms of deployment. Okay. Second of all, it required that the parties themselves issue permits for any of these research activities that would occur. So if you want to engage in this, you are associated with a country that has jurisdiction over your activities. They have to give you a permit before you can engage in these activities. Okay? Third of all, in the case of ocean iron fertilization, again, it limited it, at least currently, to purely scientific research, right? So in other words, you can still not engage in carbon dioxide removal approaches for the purposes of commercial gain, okay? And then finally, it established an assessment framework that was similar to the one that we talked about before. Now, when we look at the London Dumping Convention, there's some severe limitations on its ability to actually regulate these activities in the long term that we've talked about to date, okay? And there's several of them. First of all, the London Dumping Convention, because it focuses on placement of materials in the world's oceans, is limited to ocean-based activities and thus ocean-based geoengineering approaches, right? So it's not going to be able to regulate bioenergy, direct capture, a lot of the other approaches that we talk about by its terms, okay? A second limitation of this regime is that it has no particular expertise on geoengineering, right? It's developed some along the way, but it's clearly a sideshow, right? And clearly very limited expertise in many ways. And then finally, this protocol that would make this legally binding only comes into force if at least 47 countries adopt it, okay? To date, we've had one country. Okay, so it's going to be a long time before this becomes legally binding. So everything we've talked about is still largely voluntary in this regime. Okay? Okay, second treaty regime that has looked at this, again, in the context of ocean iron fertilization, is the Convention on Biological Diversity, right? This is a convention that was established in the early 1990s to address the alarming decline of biodiversity in the world. It establishes a framework for protected areas, monitoring, and other kinds of methods to try to reduce the loss of biodiversity. Its concern, again, was that ocean iron fertilization, because it could have potential negative ecosystem impacts, could have negative impacts in terms of biodiversity. So the CBD has done a couple of things. First of all, it passed a resolution in 2008 that called for compiling and synthesizing information about ocean iron fertilization. And it's done that. It's produced some very extensive reports that have helped us characterize and assess the potential implications of ocean iron fertilization in the context of biodiversity, at least. Okay. Second of all, it passed a resolution in 2010, right, that again limited the ocean iron fertilization to scientific research, right? So it called for the same approach, not necessarily for closing potential deployment of this technology in the future at a broader scale, but at least for now, only for scientific research, okay? And only, as you can see in the last part, if there's a need to gather specific scientific data and a thorough impact assessment report. Okay? And since that time, it's compiled a number of reports on activities of the states. Now, the CBD is also very limited in many ways in terms of looking at carbon dioxide removal approaches. First of all, it's a regime that hasn't done a very good job in terms of arresting the loss of biodiversity, right? So a lot of people believe that it doesn't have high credibility in addressing new issues, especially ones of this nature. Second of all, it also passes resolutions that are non-binding. And so from a legal perspective, anything that it's calling for is purely voluntary in terms of the parties themselves. Okay? So the question is, are there other regimes that should be brought to bear in this case? And the most logical regime, right, to be looking at these approaches in the future is obviously the Paris Agreement, right? For a number of reasons, right? First of all, we're talking about approaches that seek to address climate change. And the Paris Agreement is going to be the primary instrument, probably, that will carry us through the mid to the end of the century in terms of addressing climate change. And so that's one good reason for Paris to be the primary institution to be looking at these issues. Second of all, it is likely that if we deploy carbon dioxide removal approaches, again, it's going to be as part of a portfolio, right? We're going to be coordinating this with efforts to reduce emissions, adapt, etc. And it's going to be important to, from a standpoint of scale, to ensure that we can not deploy carbon dioxide removal approaches at scales that create huge potential environmental issues or social justice issues, and thus it's going to be important to coordinate any carbon dioxide removal deployment with aggressive reductions in emissions. And this regime can coordinate the mix between those. Okay? So again, Paris would seem to make sense. And then obviously it also has the most expertise from the standpoint of climate science and is most likely to be able to adequately characterize these approaches. And it can encompass all of these approaches and not just the marine approaches that, for example, the London Convention could. So I want to look at two questions in terms of Paris, though. The first question is, can the parties to the Paris Agreement include carbon dioxide removal as part of what's called their nationally determined contributions, right? We talked a bit about this before. Paris sets a goal, right, of holding temperatures to well below 2 degrees Celsius, aspirationally to 1.5 degrees, right? And the way this is to be effectuated is by the pledges that the parties to Paris make, which are called their nationally determined contributions, right? So the first question is, can you include carbon dioxide removal approaches as part of your nationally determined contributions, right? Well, so the first thing that we need to look at is what is the scope of the NDCs, right? So if we look at Article 4 of the Paris Agreement, it talks about parties maintaining their NDCs, and they should, and to effectuate that, they're to quote unquote pursue domestic mitigation measures, right? So the question is, does CDR fall under the rubric of mitigation measures, right? Strangely enough, Paris doesn't define the term mitigation, okay? But its parent agreement, which is the Framework Convention on Climate Change, does so, right? So in Article 4, it talks about mitigation of climate by two measures. First of all, by limiting anthropogenic emissions of greenhouse gases. That would not be relevant from a standpoint of carbon dioxide removal, but also in terms of protecting and enhancing greenhouse gas sinks and reservoirs, right? So certainly a very good argument could be made that carbon dioxide removal approaches are a method of protecting or enhancing sinks, right? Things that take up carbon dioxide. And so a good argument could be made that one could claim that one of the ways one is mitigating and meeting your NDCs is through deploying these carbon dioxide removal approaches, whether it be BECCS, ocean iron fertilization, direct air capture, etc. Now, one interesting legal question that will have to be resolved, and it could turn out to be a big one in some context, is the language here that talks about protecting and enhancing greenhouse gas sinks. Now, what enhancing seems to imply is that the sink already exists and one is simply making it stronger. Some legal experts have argued that that would preclude, for example, direct air capture from the rubric because it doesn't enhance a sink, but actually creates a new sink, right? And that's an issue that would have to be resolved. On the other hand, the parties to the Kyoto Protocol had recognized carbon capture and sequestration as one of the means of obtaining credits under its so-called flexible mechanisms, and that did that as in terms of justification by arguing that it was a sink, right? And that obviously would not be enhancing an existing sink, but creating a new one. So it may be possible that all kinds of carbon dioxide removal could be part of the mitigation strategies that countries would take in the future, okay? The second question is irrespective of whether countries choose to use carbon dioxide removal to meet their NDCs, does the Paris Agreement have other provisions that would regulate the potential scope and kinds of carbon dioxide removal approaches that could be utilized from a standpoint of protection of other interests? And I would argue that there's several that could be potentially pertinent, okay? One of them is in terms of human rights. If you look at the preamble, the introductory language to the Paris Agreement, it indicates that when taking action to address climate change, the parties are required to respect, promote, and consider their respective obligations on human rights, okay? So you have to take into account the potential impacts of how you respond to climate change. Not the impacts of climate change on human rights, but how your response measures may impact human rights. Okay? And I would argue that that could be potentially extremely pertinent in terms of many of the different kinds of approaches we're talking about. Let's start with the one that's been privileged, as Natalie indicated, so far by the international science community, which is bioenergy and carbon capture with storage, right? One recent study indicated that even if you were to deploy BECCS at a relatively modest scale of somewhere between 3 to 5 gigatons a year, okay, it would require somewhere between 7 to 25% of the net primary production on Earth, okay? It would require huge amounts of land, okay? It might require as much land as 2 Indias, okay? Most pertinently, it might require diversion of very large amounts of agricultural land to dedicated energy crops to provide bioenergy feedstock. Okay. If it were to do that, according to a number of recent studies, it could raise food prices for the world's most vulnerable peoples by somewhere between 30 and 40%. And that would obviously be pertinent to the well-recognized human right to food. right? It could substantially reduce caloric intake, and it could encroach on the internationally recognized right to food. Similarly, in terms of water, BECCS deployment, according to a number of recent studies, could require as much water as all the water that we currently use for irrigation, right? We're going to have to double that, okay? That has implications for the human right to water, and again, the human right to food because of the potential implications, as well as the human right to health, because it's likely that that substantial increased drawing down of water would degrade water systems in many areas and potentially create health impacts. A lot of the other kinds of carbon dioxide removal approaches would also have human rights implications. Even things like natural climate change solutions, such as forests, as Robin had indicated, potentially have human rights implications. One of the things that she emphasized is that, for example, we might have to grow forests on agricultural areas. If we're diverting agricultural land that's producing food, again, at a too large a scale, we potentially have implications in terms of the human's right to food. Similarly, if we're displacing people, for example, indigenous tribes or others, from land to utilize it for forests, we also have potential human rights implications in terms of protection of the rights of indigenous peoples as well as rights to livelihood, right? Ocean iron fertilization, because it could result in massive decreases in fish production downstream because of the nutrients being diverted to a new area, could have implications in terms of human rights to food, livelihood, etc. Virtually all of these would require us to take that into account. And that could be extremely important, because one of the conclusions that we might draw is that carbon dioxide removal clearly has a role to play, and maybe a critical role to play in terms of climate change. But what human rights mandate is that we utilize a portfolio approach in which we utilize a number of these different technologies at a smaller scale that might be economically optimal, but which ensure that we do not encroach upon the human rights of the most vulnerable, right? From an equity and a justice perspective, a human rights-based assessment, as mandated potentially by Paris, might help us to ensure that that would happen, okay? The second area that I think that one could argue that this would that's important is in terms of sustainable development, right? So Article 2 of the agreement talks about strengthening the global response to the threat of climate change in the context of sustainable development and efforts to eradicate poverty, right? So again, we could look at all of the carbon dioxide removal approaches through the lens of, for example, the Sustainable Development Goals that have been developed recently. And this could cut both ways, right? Given the fact that climate change, for example, could have extremely negative impacts in terms of sustainable development, carbon dioxide removal could help us in many ways to further the goals, many of those goals. At the same time, again, if we deploy these technologies irresponsibly at too large a scale, right, it's possible that we would undercut some of those, right, in terms of poverty, in terms of food, etc. Right? So again, this provides a framework that requires us to balance those interests and perhaps to be more creative in terms of fashioning a portfolio that's optimal, right? That both gets us the reductions in carbon that we're looking for, as well as protecting the interests that the Sustainable Development Goals call for. Okay? And then finally, I would say that there are customary international law principles. These are principles that apply outside of the treaty framework that would also be pertinent to looking at large-scale deployment of carbon dioxide removal approaches. One of these is what we call the no-harm principle. The idea that if you utilize your territory, you can do it in any way you wish, unless, of course, it creates harms to either the global commons or to other countries. Right? So from a standpoint of carbon dioxide removal approaches, if ocean iron fertilization, for example, were to create negative downstream impacts in the exclusive economic zone of another country, it would violate the no-harm principle and would have to be taken into account. Similarly, enhanced mineral weathering, the idea that we can mine minerals, right, spread them on the earth, and enhance the natural weathering process to increase the amount of carbon dioxide that's removed from the land, could create huge pollution issues, including transboundary pollution issues. right? This kind of principle would ensure that that's taken into account, both protecting interests internally as well as in a transboundary context. Okay? And then the last principle that would be pertinent is the precautionary principle, right? The idea that we need to be extremely careful in taking measures that are potentially have irreversible impacts, right? And hopefully will guide the research and also guide us in trying to create the optimal scale for each of these technologies. So these are some of the challenges, and they're going to have to be crafted in many ways in conjunction with the kind of national approaches that Aaron was talking about. But I think in the long term, the Paris Agreement, because it has provisions that seek to both further to the potential goal of carbon dioxide removal, but at the same time protect some of the other interests that are extremely important, may be the optimal place for us to be looking at. Thank you very much.